Hi guys, girls. Do you remember this? If you've been watching the channel since the first video I did, the first car booty, you'll recall I picked this up at the car boot sale for a few euros. I just wanted to play with it myself really, to try some macros on some of my retro games because I didn't have any keyboard that actually had macros. I mean, it's a membrane keyboard, it's not the most amazing of things, but I thought, okay, let's have a play with the macros. The guy said it was working, and yeah, sort of. It lights up. He did say it lights up, actually. He says it lights up, it's working. And it sort of works, mostly, apart from some of the keys, which don't work. So, I thought we'd have a look. This stupid thing's missing as well, which I didn't notice at the time, otherwise I probably wouldn't have even took it off him. But anyway, let's see. I'm going to plug it into the computer. I've tried this on the computer at home, so I've got it wasn't, some of the keys weren't working there. Let's connect it to this computer alongside my existing keyboard. It'll probably be quite happy to work with two keyboards. Alright, come on, get the thing into the hole. That's it, it's in. It's in. So it's plugged in. Computer says it's installing the device driver, so it knows it's there. Yeah, says it's ready for use, so it's lit up. Well, the lights are on. And basically it was working. Let's go to the desktop. I've got a little test program we can try to see what it's doing. Okay, so this is the keyboard test utility. I downloaded this. I had a quick look at it, said it was safe. I've done a virus scan on it. It seems to be quite happy. And we can just go across the keys now. Now this is a Spanish keyboard, so I'm not quite sure what it's going to do different to a normal one. Like it doesn't have a key after that. See, the number 7 doesn't work. 6, 5, 4, 3, 2. So let's see. So 2, 6, and 7 don't work. Let's try the function keys. See if they're all working. F9 doesn't work. Scroll what doesn't work. Home didn't work. Down didn't work. So we've got a number of keys here not working. Let's go across the rest of them. Tab. Yeah, 1, 0. So 2 is definitely not working. 6 and 7. Oh, that's the funny Spanish N, but it thinks it's whatever it is. Yeah. Shift. I went through, maybe the space didn't work. X doesn't work. Z. The other shift works. Control, Windows, Alt. Alt doesn't work. Space doesn't work. Alt. The other Windows key doesn't work. Control doesn't work. That Windows key does work, but this one, no, they both work. So it's Alt and Space that don't work. Yes, that Windows key doesn't work. Down, so there's just a few over here now. And the 0 doesn't work. So the ones you can see in white there are not working. I'll make a. I'll just take a quick photo of the screen. Actually, just the easiest for me, so I don't have to keep looking back at that while I'm trying to fix it. So let's have a look. 1 moment, give me a moment, and then we'll go back to the camera so you can see me. Okay, I've got a picture of the screen, so I know which keys don't work. Okay, yeah, that's. So it should be nice and clear. Yeah, okay. So let's go back to the desktop camera. So you can see what's wrong with it. I could have done it like that actually. You could have seen me all along, I hadn't realised. That's handy. Okay. Yeah. Ha, it was sitting on top of the screen. Okay, so that's what we basically have. Brightness control works for the lighting. So yeah, let's. I mean, obviously some mode keys. I couldn't really test those on that keyboard tester, I don't think. So let's unplug it from the computer and let's open it up and have a look, see what's inside this. See if we have anything that we can actually do anything with. Okay, screwdriver. Hope it's going to come apart quite easily. The screws, yeah, the screws is come loose, just rotating. Quite a few screws holding this together. And I'm guessing we have to undo them all. It's loose. I'm guessing we have to undo all of these. Soon find out. And I'm also guessing when I turn it back over the other way, they're all going to fall out onto the desk. So, that came off quite easily. I think I'll need a little plastic container. It's just a little flat box thing that'll do. Not plastic, but cardboard. Something to stick all these screws in so they don't go missing while we're working on this. Okay. I think I'm going to leave that upside down and put it on one side somewhere where it's safe. Then that should be fine. Okay, so this is what's inside it. We have some power, obviously I think it's for the LEDs. We have a connector here. We have a connector down here that looks like I can't, oh no, that's an LED. So that should just, I'm guessing that'll just lift out. Yeah, it just comes out. Bit of sellotape, high-tech, eh? Bit of high-tech stuff, sellotape. Just a job. Oh, here's one of the screws and a plastic bit. Fell off from somewhere. Sellotape. And then this is the membrane. Okay, so this is just a back piece. It looks like it's got kind of like little grids on it for some reason. I wonder if that's something to do with where the light comes through. Oh yeah, I bet this is a fluorescent panel, effectively, like an electrofluorescent panel or something like that, and or LED. I don't know, some sort of illuminated panel. I think these things here are where the light actually comes through for the illumination. So that's that, and then we have a membrane. So inside here, this is where your connections are. I'm guessing, and when you press one of these, it makes a connection. Yeah, that looks good. That's kind of like fastened down under the end of here. Little PCB comes off. Looks like that comes out. That's attached to the keyboard, so I think we have to take these out. Couple of long screws, put them in the box. Oh, looks like this. Yeah, it was just like, that's interesting. So yeah, this seems to have like connections on here that just connect to that effectively by pushing down on it. Yeah, so I wonder first thing if this is just dirty, maybe not making a connection. It's almost looks like plastic stuff, like it's you know, nothing really there. Let's get down close up to it. I mean, you can have a look, see what it is. Yeah. So this is a little PCB. Just get out of focus for you. That looks good. Yeah, it's a little PCB. This little metal cover here, and under here is like a rubbery pad. And kind of like connections, but there's also some connections on this piece as well. But they don't look like anything much really. Those, it's like, I can't say metal. I guess it must be conductive. I think the first thing I'm going to do is try and clean this and put it back together and see if it just works. Looks like this end, I'll zoom out in a minute, but I think a few keys have fell off at the other end. Yeah, so let's see if we can find some way to clean this. I'll zoom it back out again, now you can see what we have. Okay, so let's have a look at how this keyboard works, because if we understand how it should work, then it would be a lot easier in actually fixing the problem. So basically, as we've seen, we've got two of these plastic films that have these tracks on them, and these dots are conductive, these pads are conductive, so we can put a test meter for it from the little dot back to these edges, and we can actually see that that's where they're connected to. I mean, we can have a look at that now. We can see there's some tracks running around here. Let me just zoom this out a little bit so you can see a bit better what we have. Focus. There we go. So yeah, so you can see like there's some tracks here, yeah? We'll sort of go around here into these various pads, yeah? And there's a pad on the top sheet in the same place. So basically when we push the switch, it pushes the two pads together and makes a contact, yeah? That's how it actually registers that a key is pressed. If we get the meter and put it on ohms, we can just check. So let's just look on the bottom layer. So if we take one of these pins here, these tracks, yeah, and we try and make a contact with it, we should get a contact onto the pad, yeah. So you can see that's how this works. So for instance, this one which comes off around here somewhere, if I find out where it goes to, you would have a contact. It's just a matter of following it round basically. But that's how it is. Let's see if I can follow that end one. So the top one goes down to here. Yeah, and you can see on the meter there, yeah. They're not like 0 ohms, they obviously have some resistance to these tracks, but it effectively makes a contact. So that's what we have there. This little circuit board, as you can see, fits here, and on here these are marked R0, no, C0 to Z to, what's that, where we are? We have C's and R's, yeah. So we have R0 to R7. R we think is row and C is column, yeah. So we actually have 8 rows and we have 18 columns, 0 to 17 on the columns. So if you think about that, you've got 8 rows and 8 columns, yeah. And let's get a bit of paper. Let's just see how this actually works. Just make it a bit more. Zoom us out a bit. There we go. So let's see how this works with these columns and rows. Do we have a working pen? Yeah, we do. It's a red one, but that's fine. So basically, on this matrix, if you like, the bottom sheet goes to the rows, yeah? So we've got one sheet of terminals, effectively. These are like the little white spots you see on there, yeah? Red doesn't come out very well, does it, on here? Let's go. Let's find the blue pen. It comes out better on the camera. That's better, isn't it? Yeah, you can see on there. Okay. So I'll draw a couple rows of these contacts, and we can imagine they're all connected together. Yeah, this row's connected together, and this comes to this circuit board here. Yeah. and this is R0, R1 and so forth up to R8, 8 rows, yeah? Here we go. Better, much better. Can we get into focus? Too close. Much better. Okay. So we get 8 rows. One moment, I'm just going to get us focused properly. So we have 8 rows. And then also on this chip, we have a load of columns. C0, C1, C2, up to C17. This goes to R7, by the way. 0 to 7 equals 8. 0 to 17 equals 18. Okay. And again, these ones, the columns, go to the other sheet, which is all these other pads here, yeah? So, effectively, this goes like this. Yeah? And so on. And you can see that this forms a matrix. Okay? So when we push a switch, we press on these two pads to connect together. So if we push this one, we connect R0 to C2. Yeah, and only that one switch can connect R0 to C2. Only that single switch can give that combination, yeah? And this chip goes to the USB. Yeah, and it sends a command, a number, effectively, to the driver. So if you press that, it might say 40. You press that one, it might say 41, 42, and so on. And it also tells the controller whether, sorry, it tells the USB if you've pressed or released the switch. So that's how that actual lovely sharp focus. Okay, so we've got 8 rows, yeah, and we've got 18 columns, yeah. So there's 8 times 18 combinations. Well, 8 times 10 is 80, and 8 times 8 is 64. So that gives 144 combinations. And I think a lot of keyboards have about 144 keys, don't they, or something like that. That's enough combinations for a full keyboard, anyway. So that's how it connects together, yeah. Now, the way this chip works, it basically puts a voltage on each of these rows and turn all the columns. I'll have to see it's one or the other, yeah? But let's imagine it's the rows. So at first it puts a voltage on here. So this is 0 volts. This is, let's say it's 3 volts. It could be 5 volts depending on the USB. I think it's 5, yeah? So it puts a pulse on this row, yeah? And when that pulse is there, it looks to see if it gets a signal back on any of the columns. Is any button on that row pressed. Afterwards, let's draw this into context. It puts a pulse on this one. And again, when there's a pulse on this one, it looks to see is a response. By response, do I see the pulse coming back on any of these? In other words, one of the buttons is pressed, yeah? And so on. So eventually, row 2, let's just draw in context again so you can see it, yeah. So after it's tried those two, it'll come along and they'll put a pulse on that one. And you can see it does them in turn, 0 to 7, 0 to 7. So it does all 8, one after the other, with a pulse. And when the pulse is down, it looks to see if a pulse on one of these. So it can kind of go like row 2, column 16. And that will refer to a switch, yeah? And then it sends, this knows the code for that switch and sends it to the computer. And it says it's pressed this one, or it's released this one. And that's how it's working. So we can actually test this to see. Let's think what can go wrong with this first. What can go wrong? Well, this chip can be dead, so it's not sending any pulses out. So effectively the keyboard would be dead. Yeah? You can have a broken USB cable, so there's no power. On your USB, by the way, there's 4 connections, yeah? On the USB connector, this is USB, yeah? And what you have, in whichever order they are, you have 0 volts, data plus, data minus, and 5 volts. Yeah, so the 5 volts and the 0 volts power this thing up. So yeah, broken cable, broken connector, you get no power, it won't work. But say it does have power and the chip is working, yeah, you could have a situation whereby one of the rows, it doesn't send a pulse. So you can have a faulty chip. So for instance, row 2 doesn't work and doesn't send a pulse. So that means any key, which will be 18 of them on row 2, will never work, because when you press it there's never a pulse on that, so it never sees a signal. So that's where it could go wrong with one of these. Yeah, similar where this connector is here, if there's a bad connection on one of these rows, so it can never send a pulse down the row, yeah, then it'll never see any of those 18 keys. The third way this can go wrong really is if there's a problem with this plasticky conductive matrix, so that there's a break, you know, if it's cracked or something like that, or these are dirty so they're not making any contact. That's really the third way. So even though you press the switch, it doesn't make any contact, so it never sees that switch is pressed. So that's really the 3 ways in which this keyboard, and any keyboard for that matter, can go wrong. So hope you were interested in that. So let's have a look at the controller board that is here. Yeah, I'm just going to zoom down on it just one moment. I won't make you feel seasick this time, I'll do it off camera. Okay, so this is our little controller board. This connector goes to the LEDs, the backlighting, and here we can see where the signals come in from the USB. So you've got DC, V, G, and then SG. SG I think will just be signal ground, and that'll probably go to the outer braiding inside here, yeah, shield or shield ground, yeah. G will be ground, I would pretty sure. Then V is probably the voltage. C and D are probably clock and data. I said there were 2 data signals, or they're just the data, yeah. And that's what we have on here. So this will power this chip, and this is where I said you've got all these columns and these rows, yeah. The columns are in a strange order, so you've got C0 down here, then C 1, 2, 3, 4, 5, 6, 7, and then 8, 9, and then 10, 11. You can do all there, they're just in a bit of an odd order, yeah. The rows go nicely, 0 to 7. So we can test this. If we connect our oscilloscope to ground, and we then put our scope probe on each of these pins, we'll be able to see. If we can see pulses, either the rows or the columns, one or the other, we'll be getting the pulses, and it pulses each one in turn. So let's just do that. What I need to do, because I can't find a ground point on this, to connect my oscilloscope, is just to see where ground is. Let's see if we get the continuity meter here, and I'll probably have to just tag a little wire on to it, just so I can get a connection to ground. Like say tag, I mean solder a little bit of wire somewhere on, yeah. So I can see the ground comes in here, S, G and G. I can probably use either of them. Let's see if I can actually see where they go. So I think from here, yeah, I thought it'd go to the capacitor. I thought this capacitor will be on the input, so this big capacitor here. It seemed fairly obvious that was on the input, and one end will be ground, and one end will be the power. Easy way just to double check that would be just to measure the voltage across this capacitor to see I've got the right way round, and I should see 5 volts across this. So let's just plug the USB cable into the computer, and let's see if we actually have 5 volts across that. And if we do, we know which end is ground. And I think it's that top end. Okay. So that's plugged into the computer. The LED is lit up. So let's just go to volts. A bit fiddly. Can we get the meter? Yeah, you can see the meter. You can see the thing. So I think the top end of this capacitor was ground. Put the black lead on that and the red lead on the other end. Yeah, plus 5 volts. If I had it the wrong way round, it would say minus 5 volts, yeah? Minus 5. Plus 5 with the black. So we know this end here as ground, yeah? Okay, so what we're going to do here is disconnect it from the computer, and we're going to solder a bit of wire on there so I can clip my oscilloscope probe to it. One moment. Okay, so it's a resistor actually, but I'm just going to connect to this end of it. I'm not using it as a resistor, I'm just using a bit of wire. I got hundreds of these from electronics fair, amateur radio rally years ago. I was actually exhibiting there selling satellite equipment, and at the end of the day, one of the guys, like the traders, kind of left some boxes full of components on the end of the table with a sign saying "free to a good home," and there were the resistors and capacitors, old ones, and like there's all these guys there like grabbing handfuls of these stuff and throwing them into plastic bags. And I think I've probably mentioned this before in another video, but they were all taking the handfuls of this stuff for free. And like the wives who were there were thinking, "Oh God, no, what's he got now? You know, go put it back where you found it." So anyway, I got hundreds of them, and I just used my stiff bits of wire. They just dead handy. I don't know if I've actually needed one of the resistors. I might have done, but basically speaking, I used my stiff bits of wire, which is exactly what I'm doing with them this time. So let's put the oscilloscope on. I'll use my analog one this time. Let's plug this back into the computer. Okay. Let's see if it lights up. No. Yes, it's lit up. So we know the computer's seeing the keyboard. So what I can do is now just clip my ground from my oscilloscope to this point here. So I'm not going through the resistor, it's just a stiff bit of wire. Yeah, so I've got a ground connected to there now. And if I now take my oscilloscope probe and go look on these rows and columns, I should see that there's pulses on there. Okay, so let's have a look. Well, there's nothing on the rows. Is there anything on the columns? Yeah. So let's just alter the sensitivity of the scope a little bit, make it a bit bigger. Maybe too big now. Yeah, can you see that? So basically, each of the columns is getting a pulse on it. Just alter the time base a bit to make it a bit wider. Yeah. So that's the pulses we can see on each of the columns. So what I want to do now is just to make sure that every single column has pulses on it. Should do. So that one's got pulses. Yeah. Yeah. What you can't easily see on the scope is that the pulses are happening at different times. That's a completely different shape as well. Okay. Pulses. Pulses. Pulses are different shapes. Oh, that one doesn't seem to have any. That's number 11. 12. 13. Yeah, so they all have pulses on them apart from number 11. And that's nothing on it. And that's interesting. We know which keys weren't working because I took a photo of the screen. And it could be that column 11 basically goes to all the pads on the keyboard that are not working. In which case, column 11 isn't scanning, and there's a problem with this chip. So let's have a look just out of interest. I mean, it's possible that column 11 isn't used. I'm not sure how many keys are on this keypad. It may be that there's 144. Bear in mind, it's scanning the columns, not the rows, so it's working the opposite way around as I drew it on here. But that's fine. So if that wasn't working, we could minus 8 from 144. Would give us 136 keys, and maybe that's enough. So maybe 11 just doesn't scan anything. We could do that by there's two ways we could do that. One would be actually using the meter and finding column 11, see if it goes to one of the keys that isn't working. So we can try that first. The other idea, what we could do, is take a bit of wire and connect each one of these rows to one of the columns. Effectively, make a connection from row 0 to each column. And as we do that, we should be able to see on the test program, it'll think the key's been pressed. And if we can do that for each one, then we know this is working. Let's try the first way, which would be to see if we can trace the circuit on the board. Okay, let me just go to the camera, make it a bit zoomed out. So we can clearly see that column 11 isn't working. I mean, all the rest of them are working. Yeah. But we can absolutely clearly see that column 11 isn't working. And if we look at the trace on here, column 11, put it this way over, yeah, it's the 6th one in on here. And it's quite clear that 6, 1, 1, 2, 3, 4, 5, 6 goes off onto the keyboard. So it needs to work. It needs to be able to scan that column for all the keys to work. If it wasn't used, there wouldn't be any trace coming from here going anywhere. Yeah, that's fairly obvious. So this is where we have a problem with this controller board, by the looks of it. And as much as column 11 isn't doing anything. In fact, it looks like actually there's a very small, like it's trying to pulse, but it can't. Like the IC that's driving it can't drive that line. I've just turned the sensitivity up on this oscilloscope. So that's number 12. Can you see there is something on that one? Yeah? But it's not capable of driving it. Let's get the camera a bit closer to the scope. Maybe you'll see it a bit better. Okay, so 12 is clearly working, yeah? I think it's 15 is the other side, it's clearly working. And can you see that now? There's like kind of something there, but not a signal. I'll turn the scope to the most sensitive I can. 1 times 10 here. This should give it 10 times as sensitive. So that's kind of going up off the screen now, yeah. That's number 12. That's number 15. Look, and there's 11. It's trying to drive it, but it can't drive. So if that comes directly from this chip, then the chip's faulty. I don't think we're going to get a replacement for that, certainly not economically. So what we'll do is now we'll unplug this and see where that point C11 goes direct to this chip. If it goes through something else, it might be like a cracked track on here, or faulty capacitor or resistor or something. So I'll unplug this from the computer, one moment. I think we'll use the microscope actually now. Let's see if we can see where C11 actually goes to. Okay, move that out of the way. So hopefully the microscope camera's working. Otherwise I have to restart it. One moment. Which one is this? No. Okay, let me just restart the microscope camera. Okay, camera's working. Let's have a look at the little. Oh, camera was working until I just moved this. One moment. Okay, so this is our little controller board, and this is the road that isn't working, C11. And we can see there's a trace coming from here which goes up through the board here in the direction of this chip. So I would imagine that's where C11 is connecting, and it's like it's trying to drive the keyboard, but it can't. So what I'm first going to do is I'm just going to connect the black probe to ground. So this is a little wire I've stuck on here. I just want to make sure there's no short circuit from C11 to ground or low resistance, because that would cause this sort of problem. And you can see on the meter there isn't. No shorts there. So the other thing we need to check now is, does C11 go directly to this chip? Because if it does, it's the chip. There's no short, so that we've eliminated that. So straight away, first one. Can't see. Yeah, it goes to that chip. We get on it. Yeah, just a bad connection. It goes to this chip. There's a bit of resistance in this pad. They like maybe of carbon or something. Let's just try another one. C15. Does that go to this chip? Yeah. That goes up there. So C11 comes down here. Okay. So we know that C11 is driven directly by this controller chip. And that means that the controller chip itself is faulty because there's no shorts or low resistance on C11 to ground that would cause that sort of problem. So we have to say we have a faulty chip here, which I suspect means this is not repairable, but it's interesting. No even any markings. It's quite possible this is a custom-made chip, you know, that or even a programmable field, what do you call them? Field programmable grid array. It might even be a device that's just been bought to a blank and programmed for this keyboard. Okay, unfortunately that's the end of our keyboard, but it was certainly, I hope you find that an interesting repair attempt and you have some idea of what can actually go wrong with these things. Okay guys, see you on the next job, and let's hope that one is a successful repair. See you now, bye.